I started as a geographer in 2013. I did my undergraduate at the University of Leeds. And I knew I always wanted to study the environment. I grew up by the seaside, so I always was interested in nature. I always felt very at peace with nature, and so I knew that it was naturally something that I wanted to study more. So that led to a degree in physical geography. And I remember sitting down with my academic advisor on the first day and saying, I just want to explore and travel and understand the world. And he said, well, geography is the right degree to do that. So I spent 3 wonderful years at the University of Leeds, doing all sorts of field work, lab work, lectures, seminars, and discovered that I had a real aptitude for research. So following that, I did a postgraduate degree at the University of Bristol in paleobiology because I really was interested in how landscapes evolve over time. What environmental changes can we see over, hundreds of years, back to thousands of years, back to millennia, and what does that mean about changing environments in the future as well? So I tailored my research to looking specifically at past environmental change. And from that, I then undertook a PhD at the University of York looking at past sea level changes, specifically in Australia. And that's where I've kind of centered my research. That's what I do today. I look at historical sea level changes using a tiny microfossil called foraminifera. And specifically, I look at changes in sea level in areas where we don't necessarily know much about what's happened. So places like Australia and South Africa, places that haven't got these long-term records. So my research is concerned with looking at what we call high-resolution sea level changes. So I'm interested in what we call multi-annual to multi-decadal changes in sea level. So specifically, can we work out what has driven sea level in the past? And can that help us then predict what might happen in the future? So are we seeing changes from things like melting ice sheets and glaciers? Or are those changes coming from thermal expansion where the ocean water warms up? Or is it perhaps a combination of all those things and then on top there's some sort of interaction with the climate? So that's what my work seeks to do. I'm using, as I say, these long-term records where we don't necessarily have good instrumental data, trying to look at things like salt marsh evolution and the microfossils preserved within them to map changes in sea level over time. Eventually, the aim will be to build up a big database of places in the Southern Hemisphere in order to look at these regional signals in sea level change. So, are we seeing localized changes? Are we seeing common regional signals? And how does that feed into the global signal as well? And the aim will be to use all of these proxy data in tandem with both modeled and other observational data to decompose these signals in a statistical model. One of the big challenges of my research is the fact that we don't have a good global distribution of data. So most of our data comes from the Northern Hemisphere, specifically the North Atlantic. And so if we're trying to work out what global sea level's done over, say, the last 2,000 years, the Common Era, then most of our data is biased to the Northern Hemisphere. And so if we're trying to ascertain, for example, the departure from the Holocene background rate when sea levels really started rising. That's really important to quantify. When was that departure from naturally dominated sea level rise to anthropogenically dominated sea level rise? Well, if we're only having Northern Hemisphere records, then we're obviously going to have a Northern Hemisphere centric view. So that's a really big challenge for us as paleo sea level scientists. What we really need to do is try and get a good global network of data. So from places like the Southern Hemisphere and from the tropics as well, in order to try and reduce that bias in global data. So we're trying to do that, and this is pretty recent developments in the field, is using salt marshes from the Southern Hemisphere and also what we call microatolls from the tropics as well, in order to track these high resolution sea level changes. And I think that's what we're going to be working on as a community going forward, trying to reduce that global bias and generate these new records. I am part of the Sea Level Ice and Climate Cluster, so I am fortunate enough to work with people who work on issues like contemporary sea level change, paleo sea level change, different aspects of glaciology, again ranging from contemporary to paleo, as well as researchers who are also working on contemporary climate issues, great network of other scientists who are working on similar issues as me, but that may come from a different perspective. I feel very fortunate enough to be in a collaborative and welcoming research environment in the department. The department has given me opportunity to secure funds, both for things like fieldwork and lab work. So I had the opportunity to visit King Island, Australia in 2022, where I was working with collaborators from Monash University to look at sea level changes at the salt marsh on King Island. I've also had the opportunity to analyse samples for lead-210, which is a dating method that we can use to look at sediments over the last 150 years and use a decay series to work out how old those sediments are. And then finally, I've also had the opportunity to secure funds to work with international collaborators from the US as well. So we had a visitor from Durham University where we organised a series of events for the week. So we had a workshop, for example, a statistical modelling workshop. We had a film screening for early career researchers. And we also had a dialogue session where we worked out common themes between our research here at Durham and Durham University, identifying things like possible grant opportunities and other avenues for collaboration as well.